All right.
So it's inverted.
So let's skip past the thunderous applause because we're going to do some physics today. And no. We skipped past that part. All right. So physics that you need to remember, that there's this connection between position, velocity, and acceleration. Right? And these are all derivative connections. So if you had position and you found the derivative, you get to velocity. And if you found the derivative of velocity, you get to acceleration. Everybody's okay? All right. So just take a minute, read through this problem involving Josh and my friend Abraham from East End. Take 1 minute, read through this, mark it up, be ready to discuss.
No, she's out.
Okay. All right, let's get some hands on this. What do we know about this problem? I'll take anything from anybody. What do you know based on the reading you've just done? Abel.
You're starting at 0.
You're starting at 0. What does that mean?
I mean, the velocity of the graph is starting at 0.
Okay, the velocity is going to be 0. What else? Other things that you know. I'll take anything from anybody from the reading you just did. Oh my God, 1 person out of 16 did the reading. Janaea, what do you know?
Velocity is positive.
Okay, wait, velocity is positive always, according to this graph? That's not what that's telling you. Juan, what do you know?
They turn around from 4 to 6 seconds.
From 4 to 6 seconds, they're turning around. There's some of that I like, some of it that I don't like. What do we know? What else do you know from the graph? Or from the introduction to the problem that you did, that you just read? Miguel, what do you know?
That all positive values are heading west.
Okay, and I think, Janae, I think that's what your point was. You mentioned about like the v of t being greater than 0. We're not saying that the velocity is always greater than 0. I can see on my graph that's not always true. But when that's true, I'm heading west. Hello, young woman who is not in AP Calculus. What can I do for you? Okay, I'll send him in just a little bit. Careful, there's a rug there. Okay, so when the velocity is positive, the boys are heading west. Great. What am I measuring my velocity in? What are the units? Juan, what are the units going to be?
Kilometers per minute.
Kilometers per minute are going to be the units here. Last class was trying to convince me that the units were something like meters per second, and I think it's because there's a lot of them taking AP Physics this year. And everything's in meters per second. Is anybody in here taking AP Physics?
Mostly BC kids.
I know it's some of my BC folks, and some of the last, nobody in here is in AP Physics. Nope. Okay, good for me to know. Everybody's okay, units are kilometers per minute?
Yeah.
And on the x-axis? Minutes. Okay, gonna be minutes, and this is the graph of velocity. Good. So, here's my question. Looking at the graph, when are the boys going west? Just some easy entry-level questions here. Looking at the graph, when are the boys heading west and how did you decide? Boys are heading west. Salma, look at the graph. That's how you're going to figure it out. When are the boys heading west and how do you know? Jessica? When the velocity is greater than 1. Greater than 0. So when are the boys heading west? From 0 to 4 they're heading west. Anywhere else?
7 to 8.
From 7 to 8. Okay? From 4 to 6, which way are they heading? They must be heading
East.
They're heading east. East. Yeah, Miguel.
Oh, why isn't it from 5 to 6?
Why isn't it just from 5 to 6?
No, I'm saying like because isn't from 5 to 6? It's going back west because they're going back like.
No, because if the velocity is positive, they're heading west.
So what does that mean from 5 to 6?
That's a good question. So what is happening from 5 to 6?
They turn east.
Probably got chased by a dog.
From 4 to hold on, they're in my car. If you read the problem, they're probably not worried about getting chased by a dog in my sweet ride here. From 4 to 6, the velocity's negative. But from 4 to 5, you're getting more negative. So they are going faster east. From 5 to 6, are they heading east or west?
East.
East or west?
East.
The way that you're going to make this, the decision, what's the sign, the SIGN?
It's negative.
The velocity is negative, but I'm getting less negative. They are going not as fast east as they used to be going. Okay, how would I find acceleration? Okay, so I heard a lot of folks just say derivative. Now that's nice if you have an equation in front of you, but guess what? You actually don't have an equation, you've got the graph. And last class, oh boy, things were bad last period. I want to know the acceleration of the car when they've been driving for 4 minutes. How am I going to find acceleration? I heard a lot of folks just say find the derivative, but you don't have an equation. You can't do product rule, quotient rule, chain rule. What do you do, Fabricio?
Look at the graph, and if it's increasing, you know it's positive.
You look at the graph. Now, I heard way too many its. Way too many its. At time t equals 4, does anybody know anything about the derivative here?
Oh, man.
What do we know about the derivative here? Salma.
It's changing concavity.
Whoa, was not expecting that to come out. I need to know about the derivative. Another way to say derivative, I need to know about the slope. What's the slope here?
Negative.
Negative, not 0. The y value here is 0. I want the slope. The slope is going to be some negative number. How am I going to find the exact negative number?
Changing however, changing this.
Right? I've got a point on a line. Go give me the slope. While I take attendance, go give me the slope, and I want the units. 4, 8, 10, 14, 17. So just show me.
Right?
Negative 10 kilometers per minute. Wait, kilometers squared.
Where?
You don't square time.
They cancel.
That's position.
So we made it square.
Okay, all goes well. It should have -2.
Yeah.
-2. Need units though.
Kilometers squared per minute.
Right? If I'm looking at slope, I'm looking at how the velocity changed over how the time changed. The units for velocity are kilometers per minute. The units for time are minutes, so the acceleration is -2 kilometers per minute. Per minute. Another way to say that?
Per minute squared.
-2 kilometers per minute squared. All right, Janae.
I thought like we didn't square time.
When it comes to acceleration, like if you think about the acceleration due to gravity, you would say like 9.8 meters per second per second. 9.8 meters per second squared. That's how you measure acceleration.
It's like with this one that it's time squared.
Yep.
Okay.
Okay. Okay. Accelerate. I'm sorry. Let's talk about speed. What do we know about speed?
It's the absolute value.
Alejandro, what do you remember about speed?
If velocity and acceleration are both the same sign, it's increasing.
Ooh, wow. That was a whole lot more than I thought you were going to say. You said if velocity and acceleration have the same sign, then speed is increasing? Okay. So, for example, at t equals 1. T equals 1. That's not the question I'm asking right now. At t equals 1. What do we know about the velocity? At t equals 1, the velocity is positive above the x-axis. What do we know about acceleration?
It's inclusive.
Concave up.
What do we know about acceleration? I'm willing to let you guys dangle for a little bit. Maybe you need to talk to somebody near you about this. What do you know about acceleration? We've got position, velocity, acceleration. At t equals 1, velocity is positive for sure. But the velocity is also increasing. So acceleration is no. If velocity is increasing, whoever keeps saying concave up, if they could stop saying that, Miguel, that would be great. If velocity is increasing, and acceleration is not concave up, acceleration is positive. So at time t equals 1, speed is at t equals 1, velocity is positive. And acceleration is positive, so what? Speed is increasing. Okay, how about at t equals 5.5? Have a conversation with somebody near you. T equals 5.5, what do you know?
I think I need to go. Yes, negative. I think I'll be back.
Consideration context.
Yeah. So then that means
Okay, at t equals 5.5 velocity, what's the sign?
negative.
T equals 5.5 velocity, what's the sign?
Negative.
The velocity at 5.5 is
Negative.
negative. The acceleration, what's the sign? Positive, so the speed is decreasing. All right, part B, identify all intervals for which the speed of the car is increasing. Get me all those places where you know the speed is going to be increasing, and tell me why. I didn't say that. I guess. Too many its, Alma.
Huh?
Too many its. All right, speed of the car is increasing when velocity is positive and acceleration is positive. Somebody give me an interval where this is true. Velocity is positive and acceleration is positive. Jaylene? From 0 to 2, love it. From t equals 0 to t equals 2, I can see from my graph that the velocity is positive. And because velocity is increasing, acceleration has to be positive. Nice job. Any other places where velocity and acceleration are both positive? Cynthia, where else?
From 7 to 8.
Okay, from 7 to 8. So from 7 to 8, love it. Any places where velocity is negative and acceleration is negative? I need both. Need both. Brianna, where's velocity negative and acceleration negative? From 4 to 5. From 4 to 5, velocity is negative. Is the acceleration negative? If acceleration is negative, that means velocity is decreasing. Works for me. Any other place where velocity is negative and acceleration negative? No other places, right? All right, good. All right, let's check that off the list. Last one that we're going to do together. Assuming that at time t equals 3, the position is given by x of 3 equals 4. Last class we had a lot of confusion about what does that even mean. Some folks were telling me x times 3 is equal to 4. It was a little confusing for me as well. Cynthia, I love what you're doing with your eyebrows there. You're like, what? X of 3 equals 4. Salma, what does that mean?
I don't know, but on B, the 4, 5, that's also increasing.
No, velocity is negative and acceleration is negative.
Yeah, but why?
Because if velocity is negative and acceleration is negative, they have the same sign, speed is increasing.
Oh, yeah, that's
Okay, so back to my question, which is, what the heck does x of 3 equals 4 mean? One person? 2? 3? Jasmine, what does that mean?
It's telling you like the position, that's the y value, and that's the x value. So you will need that for your equation because you have x minus 3, then plus 4, and then the slope.
Right, at time t equals 3, the position is equal to 4. What I want is the equation of a tangent line. And to find the equation of a tangent line, you know there's 2 things that you need. You need a point. We've got the point. And we need the slope. So to get the slope, I need x prime of 3. But if x is position, x prime?
Velocity.
X prime has to be the velocity, right? So what's the velocity at time 3?
2.
The velocity at time 3. This is my velocity graph. At time t equals 3, my velocity is 2. Great. Write the equation of the tangent line for me. The equation of a tangent line. The slope, the point. I saw it on a bunch of papers when I was out there. I saw L of x equals 2 parentheses x minus 3 plus 4. Like it, don't love it. Won't give it full credit. Why not? Why am I not going full credit here? I've got the picky pants on. I've got the picky pants on for a reason. There is a good reason why I cannot give full credit here. Brianna, what do you say? It shouldn't be L of x, it should be...
It should be velocity.
No, I want the equation of the tangent line. Cynthia, what's the issue here?
For x, we need to use t.
Right, what you need to use is you need to use L of t because t is your independent variable here, not the x. Totally picky, depending on the day. The College Board might give you the point for it, may not give you the point for it. All right, last one. Part D, using your tangent line equation at t equals 3, estimate the position at t equals 3.3. Oh my God, we are so good at this. We are so good at the estimating game. Get me that estimate. Then my favorite question to ask teenagers, is this going to be an overestimate or an underestimate? God, I love that question. Ask it all the time. Oof. That position at 3.3. All right. So, Couple of things I'm seeing on part D. I've seen L of t equals 2 times 3.3 minus 3 plus 4. I've seen V of 3.3 is approximately 2 times 3.3 minus 3 plus 4. I've seen X of 3.3 equals 4.6. And I've seen X of 3.3 equals 2 times 3.3 minus 3 plus 4. Wait, I take that back. Okay. All 4 of these answers have a problem with them. Different problems. Each one of these 4 has a different problem. Brianna, tell me one of them. One of the problems.
For L of t,
L of t?
t is equal to
Right, you can't be using t anymore. If you're at the plug-in step, if you're at the estimation, don't write t. What are we going to write?
3.3.
You're going to write 3 of 3.3. Okay, so that's part of the problem here. Any of the problems that we're seeing? Alejandro, what else are you seeing?
For x of 3.2 equals 4.6, shouldn't it be L 3.3?
X of 3.3 equals 4.6, so you want to say L of 3.3 is equal to 4.6. Makes it a little bit better. What else? Other problems. Other problems. These are things I'm seeing on our papers. Abel, what else?
For x of t equals 2,
Yeah.
it should be x of 3.3.
It should be X of 3.3. How about this one? Brianna, what's wrong with this one?
It's supposed to have L.
Right, this guy over here is your tangent line equation. This is L of 3.3. It's not V of 3.3. Okay, so we've made those changes, and that's better. Still not 100% right. Let's wait.
And the last one, instead of x of 3.3, wouldn't it be L of 3.3?
But it's actually not L of 3.3 that I want. Go back and read the problem one more time. What is it that they want? They want an estimate for what?
The position.
The position. You have to use the position variable. You have to use X of 3.3, not L of 3.3x. So X of 3.3 is 2 times 3.3 minus 3 plus 4. And for those of you that simplified to make it 4.6, shame on you. You forgot we don't need to simplify things like this. Everybody okay with the estimate? Okay, now for the hard part. Underestimate or overestimate? Talk to somebody near you. This is always going to be the hard part. Saying underestimate or overestimate, so cute. Doesn't get you any points. You have to justify. Why would this be an underestimate or an overestimate?
I would say it was an overestimate because the tangent line is above the function.
Because the velocity is
Under. So
I'm starting to hear the good stuff now. Okay, I've heard a lot of conversations that started something like this. From t equals 3 to t equals 3.3. You have to mention an interval. From t equals 3 to 3.3. Tell me about the graph. What's v of t doing?
Decreasing.
V of t from 3 to 3.3. What's it doing?
Decreasing.
V of t is decreasing. Therefore, the position function, if my velocity is decreasing, my position function is, Alejandro?
Concave down.
Concave down. Okay, you're frozen. The position is concave down. Show me concave down. Let's see concave down, concave down. Okay, if your graph is concave down, what do you know about those estimates, Cassandra? If your graph is concave down, tell me about those tangent lines.
It will be on the top.
They're going to be on the top. They're going to be, better word would be above or over. So what do you know?
That it will be an overestimate.
Love it. Okay. Everybody good? We got things under control? Position, velocity, acceleration. Now it's time to add on definite integrals to this world. I know, I'm so excited. It makes me want to high five my neighbor too. Claudia looks like she has tears of joy. Though that could only be the reason for the tears. So let's flip it on over. I want to add on to your skill set. God, I love being a math teacher. I get to keep on pushing. Even though there's only 3 alarm clocks left between you and winter break.
Yay!
3 alarm clock settings. Jessica, can I get you to read part F?
Find the value of the definite integral at t equals 0 to t equals 5.
Definite integral from t equals 0 to t equals 5 of...
d of t times d of t.
Oh! Not times dt.
With respect.
With respect to. With respect to t, meaning t is our variable. But here's the good news. Everybody knows what they're going to do. What are we going to do?
Find area.
You're going to find...
Plug it in the cap.
No, you... Well, that would be nice. Plugging into the calculator would be nice, Brianna, but why can't you do that? Why can't you plug this into your calculator? There's a very good reason why you can't do this. Fabricio, why can't you do
There's no
that?
function.
Hold on, there's a function.
There's no equation.
There's no equation, right? You don't have an equation to type into the calculator. So good news. Juan, how are you going to find that definite integral from 0 to 5?
You could the rectangle one to like split it up into shapes.
Okay. So is this the kind of area that you can find the exact value?
Yes.
Right, we should, if those regions are shapes that you know the name of, you should be able to break this up and you don't need Riemann. Okay, finish it off.
Yes. Triangle.
I just want to take a lap, work towards my 10,000 steps. I want the definite integral from 0 to 5 b of t dt. Or as Juan said, I want the area. Lots of options. I see some people that really like their rectangles and triangles.
Yay.
I was hoping some people might like the trapezoid.
No.
Too much work, it actually saves you work. Oh, so awful. That's okay.
I just saw the trapezoid.
Jasmine, what's up?
When you don't tell us how many rectangles, can you just, I guess, make it?
Okay, but here's the point. You don't need to do that here. Look at the area you're trying to find. They're all what? Look at that. Do you have to break that up into like rectangle? Can you find the exact value here? Then go find the exact value. Okay? Okay, most folks seem to be doing triangle, rectangle, triangle. I'm going to go trapezoids.
Me too.
I see a length of 4 here, a length of 1 there. This integral from 0 to 5, b of t dt, is going to be a half of 4 plus 1. My height is 2. I bet my triangle people said 2 times 2 is 4, cut it in half. This guy over here has an area of 2. Area of 2, area of 1. You've got to do 3 sets of calculations. I can do 1 set of calculations and be done. Okay, over here, you've got a length, a base of 1. You've got a height of 2. So I know it's going to be a half times 1 times 2. And the mistake that I'm afraid somebody's going to make, I didn't even get a chance to check. What's the mistake, Salma? What's the mistake someone's going to make?
They're not gonna they're gonna think that the bottom part from 4 to 5 it's part of the area, but it's subtracted.
Right, this is actually a negative value, so I've got a positive value over here, I've got a negative value over here. This guy should be 5 minus 1, I should get 4. How many guys honestly had 4 as your area?
Error?
As the area, my bad. I went New Englander on you. 4. Now I need units. There's only one thing that could make sense for your units here. And if you're not sure, go back and think about this as area. What are we measuring the velocity in? The velocity has units. What are those units?
Kilometers per minute.
Kilometers per minute. The dt is minutes. Kilometers per minute times minutes. Those cancel out and you're going to get kilometers. Okay, one more place for me to push the thinking here. What in physics do you get when you find the area underneath the velocity curve? I know no one is in AP Physics this year, but you did this last year. It's so nice when all your courses come together. Area under a velocity curve has to give you, Josue?
Distance?
Distance, not distance. Displacement.
Really?
Really?
Wait, really?
Really. Last year, when you guys were always looking for area under a velocity graph, and I bet this is not the notation that he used,
No.
right? He would have just said, go find the area.
Yeah.
Right. This represents displacement. But I want to be really specific with displacement. Okay, number one, we're going to spell it right. D-I-S-P-L-A-C-E-M-E-N-T. Displacement from when to when? From 0 to 5. Displacement from t equals 0 to t equals 5. And I also want units. Measured in what? Measured in kilometers. Done. It's displacement from 0 to 5. Done. It was displacement. Okay. Check that off the list. Okay. Let's imagine we're in my car. My sweet ride. My sweet ride. It's a limo. Clearly. Okay. We're gonna go on I-45 north. Let's go to Dallas.
Yay, okay.
Oh!
We're gonna go 80 miles north, and then Cynthia decides she forgot something, and we head back south 20 miles. Okay, stay with me. We went north 80 miles, turn around, come back south 20 miles. The displacement? You went north 80 miles, turn around, come back 20 miles. Displacement is measure of change in position. So what's the change? 60. 60 kilometers, miles, whatever my units were there. How far have we traveled? We went north 80 whatevers. We came back 20 whatevers. How far have we traveled? We traveled 100. The difference between displacement and total distance traveled, negative area counts as positive area when it comes to total distance traveled. So with that said, I want to know how far did the boys travel in those first 6 minutes? Go get me an answer. We'll talk about it. Go get me their total distance traveled.
You add them to get there. 7. From 4, 6 minutes. Not
7.
7, that's one.
Sorry. Perdón. No. This is.
It doesn't matter. For distance, it doesn't matter.
No, but it's like what's 5?
It's 5 plus 1 plus 1, so 7.
All right, eavesdropping on the conversations. It seems pretty clear. We're going from 0 to 6. This guy over here, the area is 5 kilometers. This guy over here, the area is going to be 2. Total distance traveled?
7.
7. So you're going to add those together and get 7 kilometers. The calculus way that we're going to write total distance traveled. How do we feel about this? Integral from 0 to 6 v of t dt. Does that work?
Yes.
Hold on. Integral from 0 to 6 v of t dt. We like that? I don't.
No.
I don't. There's a problem. There's a problem. If you write the integral from 0 to 6 v of t dt, Josue, what is this really?
Displacement.
Displacement. And you guys don't want displacement. You want this negative area to count as positive area. The way that you're going to make that work, absolute value work.
Oh.
If you find the definite integral of the absolute value of velocity, because then what happens, your negative region gets flipped up above the x-axis, so that negative area will be counted as positive area. So if it's a definite integral from a point to a point v of t dt, we're going to call this displacement. If, however, it's the definite integral from a point to a point of the absolute value, total distance traveled. Okay?
Yes.
All right, show me what you can do with part H. We'll check back in a minute or two. I think you're probably thinking the trapezoids are going this way. The important thing with the trapezoid is the base is parallel. So they could go this way. That's kind of how I'm seeing it. The bottom base has an R4, the top base has a R. Okay?
For the second one, it's 7.5.
For this one?
Distance, yeah. I think they're together.
So I'm interested in you're getting a number and I'm interested in a number and an explanation. Good thing I don't wear a mic. You've got to go all the way from 0 to 8.
First one is 3.5, the second one is 7.5.
6 to 7. That's
What?
All right, I've seen on lots of papers. The first one, definite integral from 0 to 8 v of t dt is going to be 3.5 kilometers. Or you wrote it as 7 over 2 or 3.5. Integral from 0 to 8, absolute value of v of t, it's going to be 7.5. The only difference is this treatment of the triangular region. Do you count it as negative or do you count it as positive? And this first one, what was this again? Integral from 0 to 8 v of t dt represents displacement. And the other one?
The total distance.
This guy over here is total distance traveled. Everybody doing mostly okay? All right, here comes the hard part. Okay, last part. You got this. At what time are the boys farthest away from the southeast campus? Based on their graph, when are they farthest away from the southeast campus? If you're looking at that word farthest and having flashbacks, because it's kind of like the word greatest, or like absolute maximum, Fabricio, these are all good thoughts. Don't be a weenie. Don't be a weenie. farthest away you can translate into displacement is greatest. Where might their displacement be the greatest? Think about their journey. Alejandro has stolen my car. At time t equals 0, tell me what's happening with Alejandro in the car. What's he doing?
He just got on.
He just got in the car, right? What's his displacement here? 0. The boy has just figured out how to break into my car. He has not gone anywhere. Okay. From 0 to 2, which way are we heading?
West.
We're heading west. Could his displacement be greatest at 2?
Sure.
Look at the graph. Could his displacement be greatest at 2?
Yes.
Absolutely not.
I know.
Why not? Why not? Look at the graph. What are they doing at t equals 2, 1? What's happening at t
They're
equals?
staying constant. They're not moving, but they're not going down.
Okay, which way are they going?
West.
West.
They're still going west. They're still going away from the campus. Could t equals 2 be the furthest that they get from the campus? How about t equals 3?
No.
At t equals 3, I'm still going west, right? And if I look at the graph, I can still keep going west. I'm going to keep going west until I get right here. What happens at 4?
Then you
Turn around and
go east.
Well, at 4, exactly at 4,
Oh, you stop.
you stop. Okay? So over here, they're at rest. This first part, you guys said we're heading west. And from 4 to 6,
goes east.
heading east. Now, think about this for a second. At t equals 6, could that be when their displacement is greatest? Talk to somebody there, you don't talk to me. I heard a lot of folks agree that at t equals 4, this could be where their displacement is greatest. Could their displacement be greatest at 6? There's a good reason why your answer here should be no. Why? Why? Abel, why at t equals 6 is this not going to be where the displacement is greatest?
Because since you're doing displacement, you're adding the negative area.
You're adding a negative area. I was heading west, and now I've come back east. I've gotten closer to the school. So right here at t equals 4, that's a place where it could be. At t equals 6, I'm heading east. Not going to be a place. How about t equals 7? From 6 to 7, their velocity is 0. They're at a stop sign. They've been pulled over by the police. They're talking to a girl. Who knows? From t equals 7 to t equals 8, which way are we heading?
West.
Still heading west. So from t equals 7 to t equals 8, heading west. There are 2 places where their displacement could be greatest. The 2 places that we're going to check, we've got t equals 4, right? Because that's where they switch from heading west to heading east. At t equals 4, this is going to be a candidate. Yep. Candidate because the velocity makes a change from positive to negative. The other place where the displacement could be greatest? At t equals 8. The reason for t equals 8 is it's your endpoint. Way back in the day when we were doing optimization, we'd look at our candidate and we'd look at our endpoints. Now last period there was some argument about, wait a second, t equals 0 is an endpoint as well. You guys are okay, t equals 0 is an endpoint? Why are we not even going to worry about this?
That's the time to start.
Why does it not make any sense to look at t equals 0? Don't worry, I only see 3 people. Jasmine, why are you not going to consider t equals 0?
Because we haven't even started like.
So what's the displacement? The displacement is 0. They haven't moved. The way that we're going to make a decision, you're going to find displacement at 4. You're going to find the integral from 0 to 4 v of t dt. You're going to find the displacement at 8. Find the definite integral from 0 to 8 v of t dt. If you want, because you're just kind of a sick and twisted kind of person, or you just like patterns and you're going to evaluate your endpoints, feel free. I need the definite integral from 0 to 4. The definite integral from 0 to 4. You've got the graph in front of you. We've already done the calculations. 5 kilometers. The definite integral from 0 to 8 is 3.5. That definite integral from 0 to 0? 0 kilometers. Which one's greatest?
5 kilometers.
Whoa.
4.
Right. So this is displacement is greatest. All right. Done. Are you okay? All right, so here's what I want to do. I want to give you guys a couple minutes to get started on tonight's part of the homework. This is the last problem set of the fall semester. There are no more this semester. Tonight, the smart thing to do would be to focus on round 1, which is the front part. I think I'd recommend focusing on question number 2 right now. It's another velocity graph. There's questions about displacement, total distance traveled. Great practice going on there. Tomorrow night, you're going to finish up the ones in the back. The whole thing's calculator active. Okay? So you guys have some time for that. If I could see Fabricio and Abel, we'll call this the gentleman's table back here. You bring the, oh, I didn't pass back the quiz yet. I'll do that in a second. Cynthia, what's up?
So the whole thing is due Friday?
The whole thing is due Thursday. I see what you tried to do there. All right, Claudia. Stuff for you.
Don't worry, everyone has mistakes. You see in some of them, I put greater, I put my